gases, on what kind of units do we see, what kind of information do we see in the questions that are going to be seen in this chapter. So, guys, when we talk about gas, what are the things that we keep in mind? So, let's say, so imagine that I want to figure out that how much air is in a car tire. So, how do you figure out the amount of air inside? Like, what do you measure?
Pressure.
You measure the pressure, right? So the pressure gives us an idea of how much air is inside, or basically how much gas is inside, because air is nothing but different gases combined together, right? That's what the gas is. So if you talk about the pressure, then for pressure, what is the unit that we use for pressure in chemistry?
Atmosphere.
There's so a common unit is atmosphere, which is abbreviated as ATM. And then there's one more unit, which is also very common. It's called mmHg. Guys, anyone have idea what does this stand for? mmHg?
Millimeters
Something
of
per.
mercury.
Millimeters of mercury. So mmHg or torr, they're basically the same unit. Torr, which is TORR, is the same thing as mmHg. So they're replaceable without any conversion. Okay, so that's the unit you use for pressure. So guys, pressure indicates that how much air is inside a container or a wheel or a balloon. Okay, so if you talk about a balloon, so let's talk about pressure here. So imagine there's a balloon and it's inflated due to air particles inside. So guys, when we say air particles, can you tell me what are these particles? If I have to give this an identity, what do you think this is? An air particle meaning what? What is it? What is air made up of?
Molecules.
Molecules, for instance, carbon dioxide, or nitrogen, or oxygen, or argon. So all these molecules or elements that you see here, so any compound or elements that you see here, they are what are making up the air. So if you fill a balloon with air, basically you're putting in all these different gases. Now, guys, tell me, do gases have mass? Does the air have any mass to it?
No.
So is air massless? That's the question.
Mhm.
Uh,
What do you guys think? So like if you had to weigh air, does it weigh something? That's the question.
Yeah.
Yes, it does, right? So think about this. Like, what is air made up of, guys? Air is made up of all these different particles, right? Do they have any mass? Yes. We learned you can look at the periodic table and you can find their molar mass, right? You know that they do weigh something. So anything that has mass, guys, is going to put some force onto another particles next to it. So let's say if you have this gas particle here, it's going to put some force onto this wall of the balloon. This particle as well will do the same thing. So all these particles basically are bumping around and hitting on to the wall of the balloon from inside. Does that make sense, guys? What's happening here? So all these gas particles are bumping each other as well, but also they're bumping into the balloon wall. And this is what is putting the pressure onto the wall of the balloon. And that is what is keeping it inflated, right? So now, guys, tell me, if we remove all this air, why does the balloon not stay inflated? What is what is that pressure which is acting against the balloon, which is keeping it from inflating? Any idea, guys? Like, why do we need pressure from inside to keep it inflated? Why does it not just stay inflated all the times, even if you remove the air?
Because you have pressure pushing from the outside, like,
Yes,
so you
exactly.
need pressure from the inside that's stronger than the pressure from the
Right,
outside.
exactly. That's what is happening. So from outside, there is constant pressure from outside onto the wall of the balloon, and that will deflate the balloon. So to oppose that, you're filling in air and you're putting in so much air inside that the inside pressure is going to win over the outside pressure. And that is what is going to inflate the balloon. So this outside pressure, guys, what is this called? This is the atmospheric pressure. Okay, so continuously at all the times, we are feeling the atmospheric pressure, but we are so used to it that we don't realize that there's atmospheric pressure. So all the atmospheric gases, they have mass, and they are putting weight on us, and that is the force or the pressure that we're feeling from the air itself. Now, if this air was not there, then we're actually going to realize that there was all that pressure, and what will happen if that pressure does not exist anymore. So guys, what do you think will happen if you remove this atmospheric pressure from outside? What do you think will happen to the balloon? Will it become bigger in size, or will it shrink?
It'll get bigger.
It'll get bigger because you see this outside pressure is acting against the size. So if you remove the atmospheric pressure, or if you lower the atmospheric pressure, then the inside pressure is winning more. And that's why the balloon is going to inflate even more. It's going to expand more. Okay. So now we're going to see. This is what we just learned, guys. What we just discussed here is the connection between pressure and volume. So, guys, tell me, what do you think? What is the relationship between pressure and volume? Do you think they are directly proportional, or do you think they're inversely proportional? So basically, I'm asking you, if one goes up, does the other one also goes up, or does the other one goes down?
Probably inversely.
Goes
They're
down.
You have,
they're inversely proportional.
yeah.
Right, exactly. So P, so this is the sign for proportionality, guys. P is proportional, but it's inversely proportional to volume. Okay, so if the volume was to go up, the pressure will go down. Does that make sense, guys?
Mm-hmm.
If the volume was to go down, and then the pressure will go up. Okay, so this is the relationship between pressure and volume. And guys, this is this um, uh, I mean, this whole thing is called this phenomena was explained by Boyle's, and that's why this is called Boyle's law. Okay, we're actually going to see the equation for Boyle's law, but for right now, understand that that the pressure and volume are inversely proportional to each other. Okay, and we can think about this, guys. If you imagine you're going to take this balloon, or have you guys ever taken a packet of chips? You buy it from the let's say from you're in Walnut, or you're in a city which is, let's say you're in a beach city, and then you take it to a higher elevation. So let's say you take it to a Big Bear. Then what do you think happens to the packet of chips that you buy from a lower land, from
It'll
sea level?
expand.
It will expand. So why did that happen, guys? Because as you go higher elevation, what is happening to this atmospheric pressure? So guys, atmospheric, what happens to pressure as you go higher in elevation? Does it go up or does it go down?
It decreases.
It decreases. So guys, if the pressure decreases, tell me this, guys, if pressure decreases, what do you think will happen to the volume?
It'll increase.
It'll increase.
It will increase, right? That's why the balloon or the packet of chips or even the closed water bottle, it is going to expand if you take it to the higher elevation. Does that make sense, guys? Okay. Now, the same connection, guys, a similar connection can be made between different things. What are the different things that we're going to talk about in today's lecture, guys? We're going to talk about pressure, which we just did. We're going to talk about volume. We're going to talk about temperature. And then we're going to talk about moles. Okay. So guys, everyone hopefully understand what is pressure. So when we talk about pressure, pressure is when something is when the gas particles are putting force onto the wall of the balloon. That was an example for pressure. Volume, everyone understand that this is the space occupied by the gases, or the container size. So that is the volume. So I guess pressure unit we just discussed is ATM or mmHg, which is also called torr. And then volume, guys, what is the unit for volume?
Liter.
Liters. Okay. What is the unit for temperature, guys?
Celsius or
So guys,
Fahrenheit.
degree Celsius, Fahrenheit, and the third one is
Kelvin.
Kelvin.
Now, guys, for this chapter, we're going to stick with Kelvin. Okay. So you cannot forget that you must keep temperature in Kelvin, guys. Volume has to be in liters, pressure has to be in ATM, We'll talk more about that. But temperature, without any exception, for chapter number 9, guys, has to be Kelvin no matter what. Okay. Now, moles, what is the unit for moles, guys? The unit is simply mole. Okay. Now, what is moles going to indicate, guys? What does mole mean? So if I say I have 1 mole versus 2 mole, where do you have more gas?
2 mole.
In 2 moles, right? So moles is basically telling you how many particles you got. If you have more moles, that means you got more particles. So guys, if you have more particles in a balloon, then the balloon size will be bigger or smaller than previous moles.
Bigger.
It'll be bigger, right? So more moles, meaning the volume is going to be bigger. So guys, what do you think? What is the relationship between volume and moles? So when moles go up, what happens to the volume? So if I say here that the N goes up, so moles are going up, what will happen to the volume? Will it go up or down?
Up.
It'll go up. Okay, so this should be very intuitive that if you're putting in more gas, of course, the volume has to go up. So now this is the connection between moles and volume. So guys, what would you say? Are they directly proportional or inversely proportional?
Directly.
Direct.
Directly proportional. So volume is directly proportional to N. And guys, what is N?
Moles.
N is moles. Okay, so don't forget that. So the symbol for moles is N. Okay. The symbol for temperature is what, guys? Capital T.
Kelvin.
Kelvin is the unit. Kelvin is the unit. You're right. Kelvin is the unit. But the symbol that you're going to see in equations is going to be T for temperature, N for moles, and then volume is going to be capital V, and the pressure is going to be P. So if you see P written somewhere, that means it's pressure, V is volume, T is temperature, N is moles. Okay. And then these on the right-hand side, these are the units. Okay. All right, guys, any questions so far? Okay.
No.
So, guys, we just saw this pressure and volume thing. They were inversely proportional, and this was called Boyle's law. If we go down here and look at this volume and moles thing we just did, that they're directly proportional, this is called Avogadro's law. Okay. Now, so this was Avogadro's law. Now let's talk about our next variable. So guys, all of these that you see here, P, V, T, and N, these are variables, okay? We talked about P and V. We talked about V and N. Now we're going to talk about V and T, so volume and temperature. I guess, what do you think about volume and temperature? Do you think they are directly proportional or inversely proportional? Now imagine this. You take a balloon which was sitting in ice cold water, so 0 to 4 degrees Celsius, and then you take that water and then you put it into hot water, let's say 60, 70, 80 degrees Celsius. What do you think will happen to the balloon? Is it going to shrink or expand when you take it from low temperature to high temperature?
Expand.
It is going to expand. So guys, it's going to expand. That means what? When the temperature goes up, what happens to the volume?
It increases.
It'll go up.
It also goes up. So you see they're directly proportional. So V is directly proportional to T. Okay, right. Does that make sense, guys?
Mhm.
This thing right here is called Charles' law. Okay. Now, so we learned, okay, the relationship between PV, V and T, and V and N. Okay, so these were individual laws, guys, that were given by these different guys. And then after this, guys, somebody took all these variables and combined them into one equation. And that equation is called ideal gas law. Okay. Now, guys, let's see, what does ideal gas law mean? So anyone remember what is the ideal gas equation?
PV equals nRT.
Right, PV equals nRT. Okay, now, just a quick recap, guys. What does P stand for?
Pressure.
Pressure. V is
Volume.
Volume.
is
Moles.
moles, and T is
Temperature.
Temperature.
okay. So now you see this new it's not a variable, but this is actually a constant. Okay, this R here is called the gas constant. Now, you guys saw that we had proportionality signs for these. So this is not an equal to sign. V proportional to T, V proportional to N, or P inversely proportional to V. We saw we had these proportionality signs. In order to replace that and actually put an equal to sign for these, for making any equation, not just in chemistry, not just this equation, for making any of these equations, you have to insert a so a constant. In this case, it's called gas constant, okay? In order to bring that equal to sign. Now, this gas constant, we need to learn about this gas constant as well. So guys, tell me, what are the, how do you isolate R? So if the question is to isolate R, so we want to keep R on one side, what will be the variables on the other side? So I'm going to keep PV here. What do I do with this N and T?
Divide it.
Divide it out.
You divide it out. So now here, you see N and T are going to be left, right? Now, if I ask you, what are the units for R going to be? What are the units for R going to be, guys? If you put in all the units for P, V, N, and T, you will get the unit for R. So R does not have a unit for its own. It's called a derived unit, like density. You see, density does not have its own unit. Density is mass over volume, and mass is what unit, guys? Grams, and volume is what units? Milliliters or liters. So you see, density actually gets the unit from mass and volume, grams and mLs. Density does not have a third unit to itself. The same thing with R. R does not have a unit for itself. It gets the unit from P, V, and T. Okay. So now guys tell me, what is the unit for P again? For
ATM.
pressure.
ATM.
ATM. Yes, ATM. And then what is the unit for V, which is volume?
Liter.
Liter.
What is the unit for N?
Mole.
Mole.
Mole. And then what is the unit for T, which is temperature?
Kelvin.
Kelvin. Okay. So guys, see, this is the unit for R. ATM liters over mole Kelvin. Okay. Now, this could sometimes be written as this, guys. Look at this carefully, okay? You write ATM liters. You see this is divided by moles and divided by Kelvin. So instead of writing as a division sign, you might actually see this, moles -1 times Kelvin -1. Guys, this thing and this thing, they mean the same thing, okay? These units can also be written like this. That -1 actually means that they were inversed. Okay. I guess any questions on that? Okay. Now, once we see this equation, guys, this equation is talking about pressure, volume, moles, and temperature in one equation, and this is called the ideal gas equation. We're going to see what kind of questions we're going to see, and we're going to use this equation, or we're going to look at the other equations, this Charles' law, Goddard's law, and then the Boyle's law. We're going to see how we're going to be using those equations, okay? So first of all, guys, this is one equation that you should remember. Now, again, since this is going to be open book exam, it doesn't matter if you remember or not, but you're going to use this equation so many times that you already probably remember this, or also maybe remember this from introchem. So this is PV equals nRT. This is our ideal gas law, guys. We're going to use this equation to make the other equations, which is the Boyle's law equation, Charles' law equation, and the Avogadro's law equation, okay? Now, look at pressure and volume, guys. We're going to make an equation for pressure and volume. What will that equation look like? The equation looks like this. P1 V1 equals P2 V2. This basically is called Boyle's law. Okay. Now, what does this 1 and 2 mean here? So you see 1 and 2 here means before and after. So before and after. So think about this with an example, guys. Imagine we talked about the packet of chips that you buy near sea level, and then you take it to Big Bear at a higher altitude, and then you have to find out what is the new volume going to be, like how much is the packet of chips going to expand. Guys, that in those questions, you're going to be using these equations. Okay, so let's see, guys. So let's say P1, pressure 1, and volume 1. These are the pressure and volume that you had when you were at the sea level. Then you went to Big Bear, and then the pressure 2 is the new pressure. And then you will maybe asked on the exam to find the volume 2, which is the new volume that it's going to expand to. So does that make sense, guys? And what kind of question you're going to be using this equation? So if a question gives you pressure and volume before, and let's say pressure after, and ask you for a new volume, this is the equation you're going to be using. Okay. Now, any one of the variables could be missing. The pressure one or pressure 2 could be missing. Volume 1 or volume 2 could be missing. Out of 4 variables that you see here, you will be given 3 and you have to find the 4th one. It's going to be as simple as that. Okay. Does that make sense, guys? We're going to look at questions for each of these. Okay. So, so this was the ideal gas law, ideal gas equation. Now, do you guys see how you can actually remember these equations? I know you don't have to remember these equations anymore because this is open book exam, but still, I want to comment on that. So guys, a way to remember these is you see that the pressure and volume are both on the same side. If they're on the same side, you multiply them to make your equation. You see how you did P1 V1 equals P2 V2? We're going to look at another law, guys. I'm going to rewrite this equation, PV equals nRT. And let's say, guys, we were making equation between V and N. Guys, tell me, V and N are on the same side or on the opposite side of equal to sign? They're on the
Opposite.
So you see V and N, they're V and N, they're on the opposite sides of equal, like V is on the left-hand side of the equal to sign and N is on the right-hand side. That's what I'm asking, okay? So you see they're on the opposite sides of the equal to sign.
Yeah.
With this case, whenever you have to make an equation, whenever we're going to make an equation, you do this. You take volume 1 divided by N1. So you saw here for PV, you were multiplying them. But here, when it's V and N, you're dividing them. So when they're on the opposite sides, to make an equation, divide them. If they're on the same side, like you saw PV were on the same side of the equal to, you multiplied them. Does that make sense, guys? Okay, so to complete this equation, V1 over N1 equals V2 over N2. So this is equation, and this equation is actually called, what is this called, guys? V and N was called what?
Avogadro.
The Avogadro. So this is the Avogadro's law or Avogadro's equation. Okay, right. Guys, questions so far? Okay, so how many equations have you seen so far, guys? Equations, how many equations?
3.
3 equations. So one was PV equals nRT. This is our one equation. Oops. This is our one equation. Then P1, V1, P2, V2 is our second equation. Then V1 over N1, V2 over N2 is our third equation, okay? Now, guys, with the same PV equals nRT, guys, can you guys make an equation for volume and temperature? And can you tell me how is that equation going to look like? So do like V1, T1 thing. Should I multiply them or should I divide V and T? Divide. And how do you remember that? Because V and T are on the opposite side. So you're going to do V1 over T1 equals V2 over T2. Okay. So this is another equation. What is this equation called, guys? What do you think? V and T, volume and temperature?
Charles.
This is Charles' law or Charles' law equation. Okay. I guess questions so far? Now, guys, one more thing. Now look at PV equals nRT one more time. And guys, can you make an equation where I have P, V, N, and T, all of them combined? Can you make an equation for that? Like tell me what it should be on the left-hand side and tell me what should be on the right-hand side. And apply the same rules.
Do you put P1 V1 over N1 T1?
Right, exactly. So you see pressure and volume are on the same side, so I'm going to multiply them. And then the things are there on the opposite side should become the denominator. So N1 and T1. And equal, you copy the same thing again, but instead of number 1, you're using number 2. So instead of P1, this side is P2. V1, it's V2, N1 is N2, and T1 is T2. Okay. Now, guys, what did we do here? You saw we combined everything. So this is called combined gas law. Okay. So when you combine all the variables, you can call that combined gas law. Okay. So guys, if you're gonna look at these are the important equations that you're gonna be using to solve lots of questions in this chapter. So This was one equation, combined gas law. Then you have Charles' law. Then you have Avogadro's law. Then you have the Boyle's law, and then you have the ideal gas equation. Okay, so we have 1, 2, 3, 4, and 5 different equations. Okay. I guess any questions so far? Okay. Now, guys, let's look at some of the questions. So I'm going to skip these first two questions for right now, and then I'm going to come back to this. Okay. So guys, look at the question that is given here, and tell me, out of all the equations that we saw, which equation do you think is gonna work here? So don't do anything, don't do any math right now. Just read the question and see which what is given to us. So guys, give me some idea on what is given to us here. So the question is, what volume in mLs does a sample of nitrogen with the mass? You're given the mass. So the first thing you're given is mass, which is 0.245 grams. And this is mass of what gas? Which gas?
Nitrogen.
Nitrogen.
It's nitrogen gas. So guys, for nitrogen, when they say nitrogen gas, you see it does not give you the formula. So what should I say? What is this? Of what?
N2.
Of N2.
N2.
N2, yes, exactly. Because we learned that nitrogen is a diatomic, rule of 7. So when it does not say anything, when it does not give you the formula, and it simply says nitrogen, you must understand that it's going to be an N2 and not just N. Okay. Now, so you're given mass, and what else are we given, guys?
Temperature.
We're given temperature, which is 21 degrees Celsius. What else are we given?
Pressure.
Yes, torr was a unit for pressure, right? We were given pressure, and pressure is, oops, and the pressure is 750 torr. So guys, we don't worry about the units right now. Just get the basic idea of what is actually given here. So you're given the mass and temperature and pressure. So pressure and temperature, we know, we see them in the all the equations. But do you see mass in those equations that we just learned, guys?
No.
Do we see mass? No, there was no
Yeah.
mass, right? So what do you think? Instead of mass, what's the closest thing that you see here? In the
Moles.
equation, you see moles, right? So since you're given mass, guys, we can definitely change this to moles. And all of you can do that, right? So we have moles, basically. Because you know it's N2, you know its mass, you know the molar mass from periodic table, you can find the moles. So you have the N, right? So guys, you have N, you have T, and you have P. What are we looking for, guys, in the question? What are we looking for, guys?
V.
V. So we're looking for V. Now, guys, in the question, you're given N, T, and P, and you're looking for V. What's the equation that you think we should be using here? Should we be using those 1 and 2, like P1, V1, P2, V2 kind of thing? Or should we be using the ideal gas equation, which is PV equals nRT?
Ideal.
Ideal gas equation.
Ideal gas equation now. So the ideal gas equation, guys, is PV equals nRT. Now, how are we gonna be confident that you have to use this equation? So guys, you see in this equation, there's no change. Like there's no before and after in this question. Like this question does not say that this was the earlier pressure, this is the new pressure, this was the previous volume, tell us the new volume. You see that's not the case. In this question, you're just given N, T, and P and asked for V, and nothing is changing. In those cases, you must use the ideal gas law. All right, guys? Okay. Now, for ideal gas law, guys, let's go back to our units, because we first need to understand our units, and then we'll come back to what we need to do for that question, okay? So, just give me a second. Sorry. Okay. So guys, we learned of the pressure unit. So the pressure unit was ATM, or it's mmHg. So we got to learn here that how do you change mmHg to ATM. So guys, this is one unit conversion. Then 1 ATM equals, how many mmHg, guys, if you remember from intro? 1 ATM is
760.
760 mmHg. Okay, or it's also equal to 760 torr. And what is this telling us, guys? That torr and mmHg is the same thing. So torr is the guy who came up with this idea of mmHg. So that's why these units can be replaced with each other without doing any math. So guys, if I simply give you a question where I tell you that there's 700 mmHg, will you guys be able to change this into ATM?
Mhm.
Okay, reconnect my pen. Okay, so guys, if you're given mmHg and we're changing to ATM to begin with, because whatever you're given, that's where you start. So 700 mmHg, and then if you set up your conversion, again, what unit should go down here?
mmHg.
So mmHg goes down. What do you put on the top?
ATM.
TM.
ATM. Now, what is the unit conversion, guys? 1 ATM is 760 mmHg. So 1 ATM is 760 mmHg. So what do you do here, guys? You divide these two numbers and tell me what do you get?
0.921.
921. And the unit is going to be ATM, right? Okay. So guys, this is how you're going to do the conversions for pressure if needed. Now, let's look at the temperature. So guys, for temperature, if you're given temperature in, let's say, degrees Celsius, how do you change it into Kelvin, guys?
At 273.
So let's say the temperature is 25 degrees Celsius. How much will that be in Kelvin? So Kelvin.
Don't you have to subtract it to 273?
So do you subtract or add? So look at the conversion, okay? Kelvin equals temperature in degrees Celsius plus 273.15. Okay, so temperature is given in Celsius and you need to find Kelvin. So basically you're looking for temperature in Kelvin, okay? So Kelvin temperature is going to be equal to whatever temperature is in Celsius, which in this case is 25 degrees Celsius, plus 273.15. So what will be the answer? 298.15 kelvins. Okay. And guys, do not put the degree sign on Kelvin. Kelvin does not get the degree sign. Celsius and Fahrenheit have the degree sign, but not the Kelvin.
What's the conversion for Fahrenheit?
For Fahrenheit, so there's no direct conversion. So I mean, you can find one, but the common is if you're given Fahrenheit, you go to Celsius first, and then from Celsius you go to Kelvin. Okay. So you're never going to see a direct conversion. Okay. Now, so this was your temperature. We learned the pressure conversion. We learned the temperature conversion. Now the volume, you all know how to go from milliliters to liters or liters to milliliters. Now, the thing that we want to make sure here is you guys remember that we learned that for R, what was the unit for R, guys? So go back to your notes and tell me what was the unit for R?
It was ATM times liters.
ATM liters over?
Mole Kelvin.
Over mole Kelvin, right? Now, this is just the unit, but what is the actual number? What is the actual constant? The actual constant is 0.0821. Okay. Let me rewrite that just to avoid any confusion. Okay. So guys, this is what the R looks like, and you're always given that R. So the R value is fixed. Okay. So the R value is always this number. So you might be given that in that problem, or you should just keep this number handy, especially when you're going to be taking the exams online. Okay. So ours is this number, which is always the same. So guys, when you're using this equation, PV equals nRT, when you're using that equation, and R units are given that they are these units, then you must make sure that the pressure unit is what, guys?
ATM.
The pressure unit must be ATM, and volume must be
Liters.
liters, and N must be
Mole.
mole, and then T must be
Kelvin.
Kelvin.
Kelvin. So you see all these four units must match these 4 units. So, because this is the only R value that we're given. If you change these units, this R value is going to change. So never think of changing R value. Since you're always given this R value, you must change your units for P, V, N, and T to make them match with the R unit. That makes sense, guys? Questions? Questions, guys? Okay, now let's go back to the problem that we were looking at here. So guys, tell me here if you're given, let me copy paste this. All right, so guys, we saw this question. We were looking for the volume in milliliters, and you were given that the mass is 0.245 grams, and then you're given that the temperature is 21 degrees Celsius, and then we were given that the pressure is 750 torr. So guys, can you do the conversions that are needed? So guys, what should we do with the mass?
Change it to moles.
We change this to moles. So, okay, and then temperature must be changed to Kelvin, and then the pressure from torr must be changed to?
ATM.
So to ATM, right? So guys, give this a try, and then we'll go over the work for this. Okay, so for the mass, okay, so let's quickly look at the equation. So guys, what is the equation we're using here?
Or
Uh,
overall,
Yeah, overall, which equation are you using?
PV
Ideal
equals
gas law.
nRT.
Ideal gas law, which is PV equals nRT. So guys, our pressure is in torr. You're going to change it to ATM. We're looking for the volume. So guys, if you're looking for the volume, can you isolate volume? So what will volume be equal to? What will the equation look like? V equals
NRT
NRT
over
over P.
nRT over P, right? This is what the equation should look like. So if our equation looks like nRT over P, then what are we missing here? Do we know the value of R, guys?
Yeah.
Yes.
Yes, we know the value of R, which is always 0.0821. Are we given the temperature?
Mm-hmm.
Yes. Are we given pressure? Yes.
Yeah.
Wait, yeah.
The only thing missing is what?
Moles.
Is moles. And how do you find moles? If you're given
Molar
mass,
mass.
you're gonna do it right. Molar mass. Okay. So beginning with the grams of N2, what do we put down here, guys? What unit?
Grams N2.
Grams of N2, and then the top is going to be
Mole N2.
moles of N2, and then moles get what number?
1.
1.
And what do you get for mass of N2?
28.02.
28.02. Okay. Now, once you do the math, what do we get for the answer? What is the moles?
I got 0.00874.
Okay. Did anyone else got that number?
Yeah.
Yes. Okay. All right. So if that's our moles, which is N for N2, then if we see what other conversions do we need to do? This was the first conversion we did. The second is
Celsius to
for
Kelvin.
temperature is 21 degrees Celsius. How much is that in Kelvin, guys?
294.
0.15.
So you do 21 degrees Celsius plus 273.15, and this becomes 294.15, right? And that's Kelvin. So that one is done. So our temperature is done. The third one is pressure, and pressure is 750 torr. How should we convert torr into ATM, guys? What do we put in the bottom?
Torr.
Torr. And what do we put on top?
ATM.
ATM.
ATM. And what was the conversion factor that one ATM is?
760.
760 torr. Okay. So if you divide these two, what do we get?
9868.
9868. 9868 ATM. Okay. All right. Anyone else got that number too?
Yeah.
Okay, great. So now, guys, we have everything, right? We have the moles, we have the temperature, we have the pressure. So if you plug that in here, for moles, you put this number, 0.00874. I guess just for this question, I'm going to be putting the units, okay? ATM liters over mole Kelvin times.
We can't just put it all together. Like
Uh,
all of the numbers first on the equation.
Yeah, you can, sure. So you got your moles, and then your R is how much? 0.0821.
0.082.
Okay, is that what I did here? So sorry, guys. It was supposed to be moles here. Okay. All right. So this was moles times 0. Let me put the crossword multiplication sign. 0.0821, and this one is ATM liters over mole Kelvin divided by times temperature. Temperature is 294.15 Kelvin. Okay, and then over pressure, which is 0.9868 ATM. Okay, now guys, what do you think about the units? Do they cancel?
They should.
They should, right? So let's just make sure that they do cancel. So you guys see this is ATM liters over mole Kelvin, and you see moles sitting here. If you see this moles cancels this moles, and you see this Kelvin cancels this Kelvin. And then do you see this ATM sitting on the bottom cancels this ATM on the top? So what are we left with, guys, at the end? What unit?
Liters.
Liters. Is that what we wanted for volume? I mean, the question is asking milliliters, but we first get to liters and then we're going to change it to milliliters, right? Okay. So now, guys, do the math and see what you get.
I got 0.2139.
0.0.
0.2139.
Okay. Yeah, anyone else got that number too?
Yes.
Okay. All right. So this is in liters. Is that the final answer, guys?
No, change to milliliters.
The question is saying change to milliliters. So now you're going to change this to milliliters. Now you can show the work for this, but if you already know how to change this to milliliters, you can directly put the answer as well. Okay. Sorry, milliliters. Now, guys, if you're going to see a question like this on the exam, then I want to see the work. Okay. So this liters ML work, it's okay if you skip that because I understand you can do that in your head. But the other things that you're showing here, those you must show in your scratch paper. Okay. I guess any questions so far? Okay, so guys, this question is where we were using the ideal gas law, okay? So ideal gas law is used whenever you're given a scenario with all the variables and there's no change. It's not talking about before and after, okay? Now, we're gonna look at some other questions. So let's see. All right, so guys, let's just look at this question here and then see what equation should you use here. So tell me, what are we given? So we don't have to finish the whole thing.
Volume?
Yeah. So let's see, the first thing that we're given, so you're given that what our dry ice is, and then it says, what is the pressure? So question mark is on the pressure in ATM, and that's a unit for pressure. For CO2, so they're identifying for us that what that gas is. And so the first thing, liters. Again, you see guys, the word volume is never used, but they're giving you the unit, and that indicates what that is. So as you guys said, this is volume, so volume is 50 liters. Okay, what else are we given?
Temperature.
Temperature?
Given temperature is 35 degrees Celsius. Okay, what else are we given?
No,
Mass.
please
We're
don't.
given mass. Again, whenever you see mass, that's indicating that we must be finding moles from there, right? Because mass is of no use in this question. We have to change it to moles and then use it. Okay, now we're not going to finish the whole thing. But what equation do you think we should use here?
The same
one.
one. Wait.
Same
try
one, right?
this.
Of course, we're going to change the mass to moles. We understand that. So you have N, you have the T, and you have the V. You're missing P. So again, you see this question is just missing one variable, and it's not nowhere saying before and after. Like this was the pressure before, what is the new pressure? That's not here. So in these cases, you again simply use ideal gas equation, okay?
Is there any situation where you'd be missing two of the variables? No, right?
No, you'll never see two variables missing, no. Okay. All right. Now, let's look at this question, guys, and expect a similar question on your exam as well. So this one, read the question, and then we'll note down what information is given to us, and then we're going to see what to do here. So let's begin with reading the question. So it says the label on a cylinder of inert gas, basically noble gas, becomes illegible. You can't read anymore. And then, so a student allowed some of the gas to flow into a 300 ml gas bulb until the pressure was 680 m torr. This is the mass of the sample, and temperature is 27 degrees Celsius. They're asking you, what is the molecular mass? So basically they're asking you the molar mass. And they're also identifying, so they're also asking us to identify which gas is it if it's in group 8A. Okay, so guys, first of all, let's just make a list of what is given. So guys, what's the first thing we're given? Let me actually take this question. Okay, so let's see if this is our question, then not change the size for this. Okay. Because based on the information that we were given, guys, what are we given? To make a look,
Volume?
we're given,
Volume.
which is 300 milliliters. Okay, what else are we given?
Pressure.
We're given pressure. So we're given the volume. We're given the pressure. Pressure is 685 torr. Okay, what else are we given?
M?
Mass.
We're given mass. If somebody's getting background noise, can you mute yourself? 1.45 times.
Temperature.
Okay, the next thing is we're given is, so we're done with the math, then we're given temperature. Temperature is 27 degrees Celsius. Okay, so we're given all this information, and then we are asked for molar mass. So that's the question mark. We're asked for molar mass. So guys, in this equation, you see, we're given V, we're given P, and we're given mass here, we're given T. So we have PVT. That we have those three variables, but then we're given mass, and we're asked for molar mass. Okay. Now, guys, what do you think? First of all, tell me what equation do you think we should be using? Is this a before and after question?
No.
No, this is not a before after. So we will still be using PV equals nRT, or ideal gas equation. But seeing that, what do you think we're gonna isolate here in this equation?
Mass.
There's no mass in this equation.
N?
So moles.
The N, right? So the moles,
Yeah.
yes. So we're going to isolate N here. Now, once we isolate N, we're given mass. And from mass and moles, can you find molar mass? Do we have any connection between them? You guys, tell me, what is the unit for molar mass? You guys remember the unit for
mole.
molar mass?
Gram per mole.
Grams per mole. Okay, now, guys, molar mass is basically mass divided by moles, right? Grams is the unit for mass, and bottom moles is moles. Now, you see molar mass is mass over moles. In this question, we're trying to find molar mass, right, guys? If you're trying to find molar mass, we need mass and moles. So guys, do we have mass given in this question?
Yeah.
Yes, we're given mass. Do we have moles in this question? Or can we find moles in the question from the question?
Yeah.
Yes, we can. Because if I want to find moles, guys, I need P, which I do have, V, which we do have, R, we always have R, and T, we are given. So you see, we have P, V, R, and T, and we can first find moles. And we're going to use those moles, and we're going to put them here. And we already have the mass given. So you see how you'll find the molar mass? Does that make sense, guys? Questions, guys? Does that make sense? Or
Can
no?
you show
Yeah.
that part?
Yeah, we'll do that. But
Oh, okay.
does the process make sense? Like, what
Yeah.
are we given and what are we looking for?
Yeah.
Yeah.
Like, why are we isolating N? Because we're going to be putting that N in here in this equation. Okay. All right. Now, so where should we start, guys? What's the first thing we should do? So, guys, can you isolate N for me? So N is equal to what?
PV over RT.
So is it going to be PV over RT, or is it going to be RT over PV?
PV over RG.
PV over RT, guys. This is going to be this is like a very common mistake that I usually see on the exam, that instead of PV over RT, for some reason, you're going to write RT over PV. So N equals RT over PV for some reason when you're isolating this. That's totally incorrect. Okay, so save yourself from that mistake. When you're isolating N, keep P and V where they are, keep N where it is, just divide RT on both the sides, and you'll end up with PV over RT. Okay, so guys, now once we need PV RT, do we have pressure, guys? Pressure is 685 torr. Do we have to do something with it, or can we just put 685 torr?
We have to convert it to atmospheres.
Right, so we're given 685 torr. We got to change it to atmosphere. So what unit do we put here in the bottom?
Torr.
Torr, and on top,
Atmosphere.
8 ATM, and then 1 ATM is 760 torr. So when you divide them, what do you get?
685 by 60. 0.9013.
Okay, so that many ATM. Okay, then we have our second thing, which is volume. Our volume is how much? 300 mLs. 300 mLs is how many liters, guys?
0.3.
So 0.300 liters. Okay, now we have PV. Do we have R? R is always how much, guys?
0.0821.
Right. So this number is fixed, and you can use that number every time. Okay, and then do we have temperature? Temperature is 27 degrees Celsius. So Okay, so we just leave it like that, or what do we do?
You're gonna have to add 273.15.
300.15.
All right, so you'll get 300.15 Kelvin. Okay. All right, so we got our temperature, we got our R, we got V, we got P. Then guys, can you find N? So guys, do the math and find the N.
I got 0.01097.
Did anyone else got that number?
I'm gonna double check my calculation. Point.
Yes, I got that number.
All right, so that's our moles, right? Now, this is moles, and then what were we looking for, guys, in the question? We were looking for molar mass, right? And guys, again, if we remind me, molar mass is, what is the equation for molar mass? Molar mass is what over what?
Mass over
Mole.
moles.
It's mass over moles. Always remember the unit, which is grams over mole, and that will remind you that it's mass over moles, okay? So molar mass is mass over moles. So for mass, what is the mass given to us in the question? It says 1.45 grams. That's what you put in the top. In the bottom, it says you got to put moles, and we just figured that out. It's 0.01097. So you guys, when you do the math, what's the number you get?
132.15.
You get 132.15. Now, guys, this is the molar mass, so this is grams per mole. So this is the molar mass, and we gotta see the question is also asking you, what do you think this element is? Because it's group 8A. So guys, you can do the periodic table.
Xenon.
So let's look into the periodic table. Okay. So guys, we're looking at our group 8, which is the noble gases, and you see which number is closer. You see our answer is 132, which is pretty close to this xenon Xe. So your answer, so this gas that was there in that container, this is xenon gas. Okay.
For
Now,
the main answer, I got 76.03.
how much did you get
76.03.
for dividing two?
Yeah, I didn't get 132.
You did 1.45 divided by 0.01097.
Yes.
I'll have to confirm that.
You're all traded.
I mean,
I got
remember it
132.
should be the answer. It should be the answer.
Yeah, I still got 132.
Maybe try plugging it again into your calculator. It's 1.45 over 0.01097.
Yeah, it keeps giving me the same answer. I don't know why.
So let me see, where'd my calculator go? So the calculator, if you put in 1.45 divided by 0.01097, you get 132 point that number. Okay. Maybe check your calculation again, or you have something wrong in your settings on your calculator.
What's the calculator setting supposed to be on? Degree
Yeah.
or?
That shouldn't
It should be degrees, right? If something your calculator doesn't work, maybe just press the reset at the very back if you can find it.
I sent us a picture because it's being weird.
Okay. All right. Maybe use your cell phone for right now, and then figure out your what's wrong with it. Okay. All right. Okay. So we got the answer that it's xenon here. Okay. Now, any questions, guys, on this? The way to go to our next question. Okay. All right, guys. So now let's look at this question here, and then, guys, when you read this question, tell me what should we do here. So let me copy paste this question.
Changing.
All right. So guys, in this question, first of all, tell me what are we given? Let's make a list of what's given. So it says an
Initial
air-filled
pressure.
balloon, right? An air-filled balloon has a pressure of, so you're given pressure. Pressure is 3 atm. And you're also given volume, that the volume is 500 milliliters. And it says, what is its volume if the pressure is changed to 2 atm? So you see it's giving you the new pressure, 2 atm? Everyone see that in the question? So you see how you have two pressures? So you label one as 1 and the other one as number 2. So P1 and P2. So you have your volume 1, and the question is looking for what is its volume. So it's asking you for the second volume. Okay. So guys, when you see a question like this, what equation comes to your mind?
Boyle's law.
P1 V1 is equal
Boyle's
to
law,
P2
exactly,
V2.
which is P1 V1 equals P2 V2. Now, guys, let's look at the units. You see pressures in atm, so they match. Volume is in milliliters. Do we have to change it into liters, guys?
You just leave it. It didn't ask for
It
the
didn't
volume
Yeah.
in what.
Right. So the question here does not say that the volume has to be milliliters or liters. Now, for that, you can keep the unit as milliliters if you want. Okay. Now, guys, listen very carefully. For questions like this, where you're doing P1, P2, V2, or where you're doing V1 over N1, V2 over N2, your units must match for P1 and P2, but they don't have to be 18. If they were MMHG and MMHG on both the sides, that's good. That's okay. We can go with that. If this is milliliters, yeah, I'm getting some background noise. Maybe that's you. Okay.
That's my bad. There was a train.
Okay. All right. So again, what I was saying is when you're doing questions like these and your units match, you're good. You can keep those same units. You don't have to change them unless the question asks you for. But listen to this part, guys. The temperature, no matter if you're doing ideal gas equation or you're using Charles' law, temperature must be Kelvin. Okay, there's no other way around that. So this question does not care about temperature, but you want to remember, if you're doing T1 and T2, if it's degrees Celsius and degrees Celsius on both the sides, it's not going to work. You must change it to Kelvin. Does that make sense, guys?
Yeah.
Okay. Now, if you're wondering why that's the case, that has to do with the unit conversions, guys, that we need to do. For example, if you change milliliters to liters, you see you have to do division or multiplication when you go from milliliters to liters or liters to milliliters. But when you go from Celsius to Kelvin, guys, their scales are very different in the sense that you have to actually add a number, not multiplication or division. So when you do multiplication division for unit conversions, if your unit matches on both the sides, then you're good to go. And that's the case for pressure and volume. Okay. But when it comes to temperature, since these Celsius and Kelvin, they're not the same scale unit, you cannot keep it in Celsius. You must change them to Kelvin, no matter what. If you're using R in an equation or you're not using R in the equation, temperature must be Kelvin. Does that make sense, guys? Any questions on that? Okay. Now, we'll get there when we see those questions. You will see how temperature must always be Kelvin. Okay, now guys, here simply we're looking for volume 2. So guys, can you isolate volume 2 for me? V2 is going to be equal to how much? I mean, it's going to be
P1V1 over P2.
right, P1V1 over P2. And then if you plug in everything, pressure 1 is 3 atm times volume 1 is how much?
500.
500 milliliters. And then your pressure 2 is 2 atm. Your atm cancels. What's the answer we get?
750.
Right, and the unit is milliliters, right? So 750 milliliters, you can keep your answer as milliliters because the question is not asking you to change anything. Okay. I guess, any questions on this one? This one was pretty straightforward. Okay, now let's look at our next question. Now look at this question, guys. The question says you have a sample of argons. Let me copy paste this as well. Let's go down here. Okay, so now you got a sample of argon gas. It occupies 2 liters. So guys, what's that? What is this?
Volume.
This is volume. Volume is 2 liters. And then you're given temperature. It's 20 degrees Celsius. And then guys, what did it say? What will be the volume? So it's asking us for a new volume if the temperature changes to negative 10 degrees Celsius. So this is again indicating us that this is a V1, V2 and a T1, T2 kind of question. Okay. Now, since we're looking for volume and our units given to us for volume is liters and for temperature is Celsius, do we have to make any changes to our units or can we keep our units as it is?
Keep them.
Can we keep them? Can we keep?
Wait, no, they have to be always Kelvin.
Yes. So guys, this
for
is where,
temperature.
Right. So this is where I want to mention that temperature, no matter their Celsius and Celsius, no matter this question uses R or not. Now you guys remember which equation uses R?
Ideal.
The ideal gas law, ideal gas equation uses R. So in that equation, PV equals nRT, where you're using R, your units must match with R, which is ATM, liters, moles, and Kelvin. That one is 100%, you have to stick with those units. But when it comes to these equations, P1, V1, P2, V2, V1 over T1, V2 over T2, questions that actually do not need R, your units must be same on both sides, then you don't have to change the unit unless it's temperature. Temperature, no matter you have R or no R, your temperature must be Celsius, must be Kelvin. You must change it to Kelvin. Okay. All right, guys, so if you do that real quick, what is our temperature one gonna be? So if we add 273 to this becomes 293.15 kelvins. And this becomes how much, guys? Negative 10 degrees Celsius is how many Kelvin?
263.15.
Right, so you're going down, right? Because it's negative 10. So 263.15 Kelvin. Now, this is your temperature 2 and temperature 1. Your volume 1 is 2 liters. Now, guys, and we're looking for V2. So, guys, what is the equation again? Can you remind me what was the equation? V1
over T1.
Right, it's V1 over T1 equals V2 over T2. And guys, what are we looking for? V2. Now, guys, can you isolate V2, please? Guys, what is V2 equal to?
Wouldn't it be T2 V1 over T1?
Right. So this T2 can be taken up here, right? So it's T2 V1 over T1, right? Now, guys, if we plug in all the numbers, our T2 is how much? How much is T2, guys?
263.15.
Right. Now, guys, and what is the volume 1 times volume 1?
2.
So volume 1 is given to us as 2 liters. Okay. And then temperature 1 is 293.15 Kelvin. Now, guys, the only thing that you can mess up in questions like these is 2 things. One is the unit that you will forget to change it. The second is, guys, look here. When you're going to be putting these numbers in, let's say you plugged in the V1, and when you're going to be doing this on the exam and you're in a hurry, then maybe when you're going to see V1, next to it, when you're putting the temperature, you're going to pick this temperature T1 just by mistake, just because you did not read this carefully, that this was T2. You're just doing this so quickly that you just put in the T1. So you exchange T1 and T2 in your problem. So never do that mistake. So for avoiding that, you should make the list given to you, like what is T1 V1 and what is T2. So make a list of the variables you're given, so that when you're picking them, you can more easily plug in the numbers. Okay. Okay. So now when you solve this, what do you get for V2?
1.795.
1.795. You see Kelvin canceled. What are we left with?
Liters.
Liters. Okay. Is that what we're looking for, guys? Does the question say anything about the unit?
I don't think so.
Nothing. So if it does not say anything, and keep it like that, or you match it with the options you're given on the exam. Okay. You guys, any questions so far?
No.
Okay. Now, let's look at this question right here. I guess look at this question, given the details that were given, and then tell me also the equation that we should be using. Okay, so let's see what variables are given to us, guys. So what's given here?
Initial volume.
Right. So the question is saying what will be the final pressure of a sample of nitrogen gas with the volume. So we're given a volume. Volume is 950 meters cube, and then it says what is this, guys? 745 torr. What's that?
Initial pressure.
That's the pressure, 745 torr. And then what else are we given?
Initial temperature of 25.0 degrees Celsius.
Right, so we're given temperature as well. And then the question says, if it's heated to a new temperature, so you're given another temperature, so we're going to call that T2. So temperature 2 is 60 degrees Celsius. So yes, again, when you're going to be reading the questions, you'll quickly realize that the question is the before and after question, okay? So then you can put in the numbers 1 and 2. Okay, you're given temperature, and then you're given the final volume. So you're given V2, and that's 1150 meters cube. And then you're looking for P2, because the question says, what will be the final pressure? So you're looking for pressure. Now, based on what you're given, guys, what equation do you think we should be using?
Combined gas law.
Right. The combined gas law, if you, again, it's not important for you to remember the names for them, but if you just remember what was the equation like, and if you want to make an equation, you can always make the equations that you want. So guys, in this question, what are the variables that are changing? So if you would just want to label them in this equation, guys. Is P changing?
Yeah.
Yes. Is V changing?
Yes.
Yes. Is T changing?
Yes.
Temperature is changing, right? So R is a constant, so that never changes, not even a variable to change. And moles in this question, the question is not even talking about moles, so that means it's not changing as well. So P, V, and T are changing, guys. Can you make the equation for this? What will the equation look like?
P1 V1 over T1.
Right.
Equals.
Since only P, V, and T are changing, you make an equation that only has P, V, and T. Okay. And then P2, V2 over
T2.
Okay. So this is what your equation looks like. Now, guys, before we do anything else, in
I
this
have a question.
Yes.
When you're making these equations, does that mean every variable you have has to change? Like, can you still do this equation if, for example, there is no new temperature?
So then you will ignore T1, T2. The T1,
Oh,
T2
okay.
will not exist there. Your equation will be P1, V1 equals P2, V2, which is actually both.
Okay, thank you.
Okay. So the variables that are changing, you only put them into the equation.
Mm-hmm.
Okay. All right. Again, guys, in this question, we were looking for P2, right? If you're looking for P2, guys, can you isolate P2? So P2 will be equal to what?
P1 V1 T2 over T1 V2.
Right. So we see P1 and P1 stays where they are. P2 stays where it is. You take the T2, you put it up here. You take the V2, you put it down here. So T2 reaches on top and V2 is down here. Okay. Now, before we start plugging in numbers, guys, do we have to change any units?
Yeah.
What about volume, guys? Can we keep meters cube, meters cube?
Yeah.
Yes, because volume is okay. You can keep the same unit. If you have the same unit, that's fine, as far as we're not using R. And in all these questions, there's never, R is never there. It's a constant. And temperature, guys, is Celsius okay? Both of them are Celsius?
No.
No.
Must change to Kelvin. So 25 is 298.15 Kelvin. And 60 is how much, guys?
333.15.
333.15 Kelvin. So this is your temperature 1, temperature 2. So guys, now if you start plugging in everything, our pressure 1 is given to us, which is 745 torr, times volume 1 was 950, times, what's the temperature 2, guys?
Temperature 2,
It's
33315.
333.15. Okay, so this is, guys, again where I was cautioning you that, look here, guys, on the screen. You see this is 1 P1 V1, and when we were doing this on the exam, we were in a hurry. We're gonna put T1 here by mistake, so don't do that mistake. Okay, it's a very common mistake on the exam. Over this is T1 then. So that's why if you make a list on the top, it's gonna be much more handy to go and follow back what are we looking for. Temperature 1 is 25 degrees Celsius. Oh, no, sorry, 25. I'm sorry. You're gonna put 298.15 Kelvin times our volume 2. Volume 2 is?
1150.
Right. So I guess quickly let's get the units. You see meter cube gone, Kelvin gone, and you're left with torr. Is that what we want at the end?
Yep.
Yeah, we want the pressure unit, right? So guys, do the math and see what you get.
I got 687.7.
0.7 torr. Okay, sounds right. Right. Everyone else got that number?
Yep.
Okay, great. All right, guys. So, any questions, guys, on this?
No.
No? Okay. Now, so guys, we talked about our, so these questions that you're going to see here. Okay, so whatever we did so far was with the ideal gas law and then the different before and after questions, okay? Then the next thing that you can see, we can actually discuss that next in our next lecture. And this is about stoichiometry, guys. So stoichiometry is going to come back. And if you understood your stoichiometry from chapter 4, which is you need to go from moles to moles, the same thing is going to work here, guys, as well, okay? Now, what do you think will be different here? The way to get to moles will be different. Like in chapter 4, guys, how did you change, what did you change to moles? Like what was given to you that you changed to moles?
Moles to moles?
Right, but what were you given? Let's say you were given the reaction where A plus, yes, grams. Let's say a question where you're given A plus B equals C, guys, this is not for this question, okay? So A plus B equals C, remember you were given grams for this, and then you were asked for grams of this, and then for this you went to moles, and then moles to moles and moles to grams. That's what we were doing, right? In this chapter, instead of me giving you grams, you see this is a gas, so you're not going to be given grams. What do you think you'll be given to get to moles? Like today, what were you using? What information was given to you in the questions that were looking for moles?
Pressure, volume, and temperature.
Right. So you will be given PVT. You use that to go to the moles. Okay? Because this is a gas chapter. That's the only difference, guys, in stoichiometry for chapter 9. Everything else is going to be the same. The concept of stoichiometry is still the same.
So you use those 3 to get N?
Yes.
Like in the
So
ideal.
you're going to use PV equals nRT equation, and you're going to find N. N will be equal to PV over RT, and PVT will be given, R is a constant.
Okay.
Okay, so instead of chapter 4 where you had mass to moles or you had volume, you use molarity to change to moles. Here, you're given PVT to get to moles. But the point is, again, to get to the mole so that you can do mole to mole ratio. Okay. All right. So guys, we're gonna continue with this thought on the next week, but let's go back to the first question. Okay. Now, let's talk about the equipments, guys, that are actually used to figure out the pressure. Like when you measure the pressure, like the atmospheric pressure, like you know that what is the atmospheric pressure, guys, at sea level? So
1,
At-
I think.
atmospheric, right? So atmospheric pressure at sea level is 1 atm. So guys, that's how many mmHg?
760.
760, right? So this is how it was actually defined, that we started saying, okay, the sea level is 760 mmHg. So we're going to start calling that 1 atm. That's how it began, okay? So that's how this equation came in. But the idea is, where did this mmHg come from? Like, what's the idea behind this?
Millimeters of mercury.
Right? Millimeters of mercury. So by millimeters, you must be thinking that there must be some scale which is measuring something, the length, right? Millimeters is the unit for length. So guys, the equipment that was used to find out the pressure is called barometer. Okay. Now, if you were in the lab, then you would have seen what the barometer looks like. Let me actually go and Google search if you can see the image for barometer. Okay. So you can see this is what a barometer looks like. Now, these are, of course, the fancy ones, okay? But you see, look at, this is like just a digital cartoon that you're seeing, that this is the scale, like for temperature, but for the pressure, you use a barometer instead. Let me see if it gives you, yeah, here, look at this one. Look at this image, guys. So guys, what happens here is you see this tubing? This tubing, you see all these, you see this is millimeters on the very top, and it's giving you all these numbers here. It should not be, it's a millimeter, it should be centimeters. Okay, so you see this is around 700 or this is around 800. So if the liquid, you see this liquid here? This is just like thermometer. You see this shiny liquid inside this glass tube, and this gray or silver looking liquid can actually move, guys, up and down. Okay, so wherever it is, that's the pressure. So if it's sitting right here, you're just gonna read, if this is 90 and this is 100, this is around 98. So you're gonna say, okay, that's 98, whatever the unit is. M bar is the unit that is given here. Okay, this is measuring in a different unit. But the idea is this, that this liquid can actually move in this tube, and based off what is the length of the liquid in the tube, you say that is the pressure. Okay, that's the idea behind it. So let's see actually how it works, okay? So let me give you a simple drawing for a barometer. So guys, there's a container, which is an open container, and there's an inverted tube sitting inside the container. This inverted tube, guys, has the markings, like what we just saw. There was the glass tube, which has the readings on it. And guys, this container is filled with some liquid. What do you think that liquid is?
Mercury.
This is mercury. So you take the mercury liquid, guys. You see this bottom part is open. So since this is open, the liquid can actually get into this tubing. And guys, you see this is open. This is an open barometer. So this side is open, meaning that this is open to the atmospheric pressure. Okay, so guys, tell me, if this pressure from outside, this is atmospheric pressure, guys. If the atmospheric pressure goes up, what do you think will happen to the liquid sitting here? Is it going to go into the tubing, or is it going to come out?
Into.
It'll go in. So once it goes in, you see the mercury level inside will go higher and higher. As it goes higher, that's the reading that you take. And if you take this barometer at sea level, then you're going to see that this liquid is sitting at 760 millimeters. So then you call it 760 mm. And since the liquid is Hg, you add mmHg. Does that make sense, guys? Where does this mmHg comes from? Okay. Now, what was this called, guys? This is a barometer. What is this used for? Guys, what did you measure here? Did you measure the pressure of the container or the pressure of the atmosphere?
Atmosphere.
The atmosphere, guys. So the barometer is used for finding not just any pressure, but the atmospheric pressure. So not the pressure of your car tire, but the atmospheric pressure. That's what the manometer is used for. I'm sorry, that's what the barometer is used for. But the another meter, which is called manometer, is what you use to measure the pressure inside the container. So inside container pressure. Okay. Okay, so let's see how that works, okay? It's very similar. The way it works is very similar. So let's see that there's a gas container. So imagine, guys, you must have seen those oxygen cylinders, maybe in hospitals, where, so this is, let's say, oxygen gas sitting inside a cylinder, or maybe liquid nitrogen, or maybe the propane gas. You might have seen the propane cylinders and how they have actually a meter on the top that tells you what's the pressure inside. So this is oxygen gas. And guys, the gas container is actually connected to a tubing. Okay. So guys, this tubing, it's open from this end. So that's why this is called open end manometer. Okay. So guys, look here on the screen again. So guys, this container is filled with, you got to mute yourself, whoever's the noisy spot. Okay. Right. So guys, you see this, what is this liquid again? What do you guys think this liquid is?
Still mercury.
Mercury again. Now, you guys look here. You see this is open. So the pressure from outside, which is called the atmospheric pressure, is acting from outside. So this is the atmospheric pressure, which is putting the pressure from outside to inside. So the atmospheric pressure, let me get some more space. Okay, so this tubing, it's feeling the atmospheric pressure from outside. Okay, so atmospheric pressure is putting the pressure from here, this way. And guys, you see this is oxygen gas, so it's also putting the pressure this way. You see how they're acting against each other? So the gas is gonna put the pressure from here, the oxygen gas, and the atmospheric is putting the pressure from here. Now guys, you see this is liquid mercury, so this can move up and down. So guys, if I move the liquid higher, if it goes higher and it goes lower on this side, guys, can you tell me then who is winning here?
Oxygen.
So if this side is going down and the other side is going up, then that means this oxygen pressure must be more than the atmospheric pressure. Does that make sense, guys?
Mm-hmm.
That's why this side is going down and this side is going up. Okay, so you can actually find the pressure for gas, which is oxygen in this case, by adding to the pressure of the atmosphere. What do you add? You add whatever is the difference. So whatever is the difference here in mmHg, so whatever this liquid rises by, that's what you add here, plus mmHg. Does that make sense, guys, here?
If it goes in the other direction, are you subtracting mmHg?
Yeah, exactly. So the pressure of gas can also be the pressure in atmosphere minus the mmHg. You call this is the height. Okay, so h, I'm calling that h. So whatever is the height difference. So if this one rose by, let's say, 60 millimeters, you're going to be adding 60 mmHg to whatever is the pressure of the atmosphere. So if the pressure of atmosphere was 760 mmHg, let's say this reaction was, the container is sitting at sea level and the atmospheric pressure is 760 mmHg, and then the height here, the h, is equal to 60 mmHg, guys, then what will be your answer for the pressure of gas? First of all, tell me, which equation should we use, number 1 or number 2? The first one. Why? Because here the gas is winning over the atmosphere, so gas must be winning over atmosphere, meaning you got to add to the atmosphere to get the gas pressure. Okay, but if it's the other way around, let's take the example of that too. So let's say you had the same, you have the oxygen gas cylinder, it's connected to a manometer. Okay, now in this case, let's say the liquid actually is higher on this side versus the other side. Now again, you have the difference in the height. Now this time, again, the atmospheric pressure is acting from the top. Now guys, who is winning? Is atmosphere winning or oxygen gas winning?
Atmosphere is winning.
The atmosphere is winning. So you have to subtract from the atmosphere to get the pressure of the gas, because pressure of gas is less than the atmospheric pressure. Okay, so in this case, you must subtract. So based off where you see the manometer is headed, you're going to decide if you have to add or you have to subtract the height to the atmospheric pressure. Does that make sense, guys?
Yeah.
Okay, now let's read this question real quick and tell me what equation should we use. Let me copy paste that here. Yes. So a student collected a gas in apparatus connected to an open-ended manometer. The mercury in the column open to the air. You see, open to the air was 120 mm higher, and the atmospheric pressure is 752. What is the pressure of the gas, guys? So pressure of gas equals the pressure of the atmosphere. And now guys, should I add or subtract the height?
We add here, right?
We add here. Why do we add? Because what it's saying, the mercury in the column open to the air was higher. So it's this scenario here where the mercury open to the air is higher. Okay, so for that you need to add and not subtract. So you got to add the height here. Does that make sense, guys? Now the pressure for atmosphere is given, it's 752 torr. And guys, what is the height? 120 mm. And since it's mercury, you can say it's 120 mmHg. Now guys, can you add these two units? Are they the same unit?
They're not the same unit, but they basically are the same, right?
Yes, yes. So they're not like literally the same unit, but they actually, if you do the conversion, you don't have to do any math for their conversion. You can simply change torr to mmHg without doing any calculation, right? So even if you're doing this on the exam and you keep torr plus mmHg, that's okay. You're not going to lose any points for that. But you understand that they should match, right? mmHg or torr is the same thing. Now, guys, if this pressure in ATM was given in ATM, then will you have to change it to mmHg?
Yes.
Yes. So, guys, don't do this, okay? If pressure in ATM was given to you as 1.1 ATM, then do not add 120 mmHg to that. That's not going to work because they're two very different units. You'll have to change this ATM to mmHg. Okay? And then you add them together. And then your answer will be an mmHg. Right, does that make sense, guys?
Yeah.
Okay. Questions so far on this? Okay, 752 and 120 is going to be 872 mmHg, and that's your final answer for this. Okay. Questions, guys? Any questions? Okay. All right, guys. So I'm going to end for the lecture portion here, and then you're going to start talking about the lab. So I hope you guys already did their pre-lab for this lab. And let me show you what exactly you need for completing this lab, okay? So what we're doing here is basically I have the instructions here for you. So read this carefully when you're going to be when you're going to start writing the lab report. So as you see here, what you're doing is you're doing some chemical reactions here. So you're going to be reacting a few chemicals, and then you're going to be making observations. So basically, let's say that you're adding two chemicals.